Hello Year 5 and welcome to Week 6, Monday's maths session for Blue and Green Group. Today we're going to begin with a little bit of work on multiplication. We're going to actually have a little look at multiplying three numbers together. This often comes up quite a lot in your arithmetic test, and what we really want to focus on today is trying to find the most efficient and quickest, obviously still accurate, way of solving these types of questions. So I've put a little question up to begin with, and you might want to pause the video, and this is almost a sort of how many different orders can you find? It says how many ways can you reorder this calculation? So I've got here 4 times 6 times 5. Now when we multiply, we are actually able to use the commutative law, and what I mean by this is it doesn't matter what order we multiply in, we will still get the same answer. So obviously we've got here 4 times 6 times 5. I'd like you to think about what other orders could you multiply these numbers in. If you pause the video now. Okay, so this might be some of the ways that you have found. So I've got here 5 times 4 times 6, 5 times 6 times 4, 6 times 4 times 5, 4 times 5 times 6, and 6 times 5 times 4. Now what we're going to try and work out today is actually what is the most efficient way of calculating these three numbers we need to multiply. So I want you to think about now, which one do you think is the easiest? So I'm going to start over here with this red one, where everything is in the same order as it originally is in the question. So first of all, we've got 4 times 6 is 24. Then we needed to do 24 times 5. Now in order to do that, I needed to do 20 times 5 and 4 times 5. So you can see here I've partitioned 24. I've worked out what 20 times 5 is, which is 100, and 4 times 5, which is 20. And I added those together, which gave me the answer of 120. Okay. Then I did it in a slightly different order here in blue. This time I actually started with the 6 times 5. So I had 6 times 5 was 30, multiplied by 4. I know that 3 times 4 is 12, so 30 times 4 is 120. And finally down the bottom here, 4 times 5 is 20, and then I had 20 multiplied by 6. I knew that 2 times 6 was 12, so 20 times 6 was 120. And I want you to just think about which one do you think is the easiest? When I had a little look at this, my thinking was either this blue one or this green one was the easiest to do. And that's because I've multiplied one of these numbers by 5. Now because these numbers are even, the answer multiplied by 5 was obviously a very nice multiple of 10, yeah, where we've got a 0 in our ones column, which made it much easier to do this second multiplication sum. So actually, if you've got three numbers to multiply together, it's a really good idea to start with multiplying the 5 by the even number. Now obviously 4 and 6 are both even numbers, but let's say for example this 6 was actually a 9, it's going to be much easier to multiply by the even number first. And although I did this quite quickly, there was some partitioning to try and hold in my head. So one of these two was probably the easier. Now let's have a little look at this one. So we've got 3 times 10 times 6, and I want you to have a little look at my 3 different ways of reordering the calculation here. Now actually, as you can see, because one of those numbers is 10, I didn't actually need to do any partitioning in my head. So we've got 3 times 10 is 30, 30 times 6 is 180, 3 times 6 is 18, 18 times 10 is 180, this one here, and then down here 6 times 10 is 60, and 60 times 3 is 180. I would probably say they are all on par, so no one is probably easier than the other. If I was swaying, I'd probably say I'd multiply by 10 last, because actually it was very quick for me to recite my 3 6 times tables, and we've worked on multiplying by 10. So if anything, if you see a 10 in your numbers to multiply together, it might be worth leaving the timesing by 10 till last. And a third one, I'd like you to have a look at this one, 6 times 7 times 2. So as you can see here, 6 times 7 is 42, 42 times 2 is 84. We've got here 2 times 6 is 12, 12 times 7 is 84, or 7 times 2 is 14, and 14 times 6, I had to do a bit of partitioning, 10 times 6 and 4 times 6, which obviously gave me 84. So we can probably rule out that probably this green one here was probably the hardest due to the partitioning. And if I had to make a choice, I'd probably say I found leaving the timesing by 2 till last the easiest, because all I had to do was double this answer. And sometimes we can find our 12s and 7 times table quite tricky. So here it might be worth, if you've got a 2 in your 3 numbers you're multiplying together, to leave them till last. So I'd like you to pause the video now, and I'd like you to have a go at just exploring multiplying these different sums together and thinking about the order that you're going to multiply the numbers together. Notice that we've got a 10 here, we've got a 2 here, we've got a 5 here, a 10 again and a 2. And we've just talked about thinking about how multiplying by 5 first with an even number often makes it easier, and leaving our 10 or our 2 till the end. So have a little look and explore it, and you might decide you're going to show more than one way of doing each calculation, and just have a play around really with the numbers to see what you found the easiest. If you'd like to pause the video now. Okay, so again, there's no right or wrong answer here. This is the order of the sums I found the easiest to do. You can see here I left my timesing by 2 and by 10 till the end, and with this one here where I had a 5, I multiplied it by the even number 6. So 5 times 6 is 30, and then I did 30 times 9, 3 times 9 is 270. So you can just have a little look at those there. And you can see here with this 7 times 8, I know that 7 times 8 is 56, so then I doubled 56. 50 and 50 is 100, 6 and 6 makes 12. And this one here, 7 times 3 is 35, and then I times by 10. And 9 times 4 is 36. I doubled 30, which gave me 60, and I doubled 6, which gave me 12, so 72. Today we are going to be exploring adding and subtracting fractions with different denominators. Now we have looked at this before in class. It's a little bit of a tricky part of maths to do, but you did really well with this when we've explored it previously in the autumn term. Now to be successful today, bar models are going to be really useful to represent fractions. So just a reminder that bar models, we use these to try and represent questions. And as we go further through the school, we come to more complex maths questions. And if we've got a good understanding of how to use those bars, it can really help us to break those problems down. We're going to need to identify the values of denominators and numerators in the fraction. So the numerator being the top number and the denominator being the bottom number of a fraction. And we're also going to need to use knowledge of factors and multiples, and this is really important. Where the denominators are different, we're going to need to be finding some equivalent fractions. So just a quick reminder, if the denominators were the same, when we're adding fractions with the same denominators or subtracting fractions with the same denominators, the denominator stays the same. It's just our numerators that we calculate. So when we come onto our challenges where the denominators are different, this is where we need to use knowledge of equivalent fractions. So I've just got an example here. 2/6 is equal to how many 18ths? And what we need to think about is, how do I multiply? How do I go from 6? What do I multiply by to make 18? And the answer is 3. So you can see in my bar model here, each 6th has been multiplied by 3 to give me 18. Now whatever we do to that denominator, we need to do to the numerator. So if I just show here with my colour, I've obviously got 2/6 here. So I've multiplied by 3. 6 times 3 is 18. I need to do the same to 2. 2 times 3 is 6. 1, 2, 3, 4, 5, 6. And you can see that that is the same. They are equivalent fractions. So whatever you multiply your denominator by, you multiply your numerator by. So I'd like you in a minute to pause the video and just have a go. You don't need to do all of these, but just have a go at a few of them, working out the equivalent fractions. So let's do a couple together. We've got 4 3/4 equals something 24ths. So 4 multiplied by what is 24? 4 multiplied by 6 is 24. 3 times 6 is obviously 18. 1/3 is equal to 12ths. 3 multiplied by 4 is 12. Therefore 1 multiplied by 4 is 4. 3/7 is equal to something 14ths. 7 times what is 14? 7 times 2 is 14ths. So 3 times 2 is 6. And finally down here, 9 times what is 18? 9 times 2 is 18. So 5 times 2 is 10. So we've done a few there all together. Now you can have a go at a few on your own if you'd like to pause the video now. Okay, so here are the answers. Don't worry if you didn't do them all, you didn't need to, but this is just a really good way to just remind ourselves of how to find equivalent fractions before we move on to looking at adding and subtracting with different denominators. So again, another little pause of the video just to explore. Now, I've got a calculation here which says 2 24ths plus 1/6. And these 3 children, Molly, Rory and Fred, have had a go at working out the answer. So Molly said, I think 2 24ths plus 1/6 is 3/30ths, because 2 add 1 is 3 and 3 add 6 is 9. Okay, so I'm not quite sure what Molly means there by the second one, but maybe you do. I think it's 6 24ths, but I don't know why. Okay, so you might have a little look and think, do you agree? Maybe do you know why he's come to this answer? Do you agree with Rory? And Fred said, I think it's 3 24ths as 6 lots of 4 is 24. So have a little look. It's not necessarily that any of them are right. Is there anyone that you agree with or you strongly disagree with? You might want to jot down some notes now, or you might want to talk to somebody at home about it. Okay, so what we're going to do now is we're going to work through some examples. We will come back to this question in a moment, but we're going to work through some examples of adding and subtracting fractions where the denominators, this bottom number, is different. So we've got here 3/9 add 1/3. Now the first thing we can see is our denominators are different and we need our denominators to be the same. So our first step is to find an equivalent fraction. So we tend to start with our lowest number, our lowest denominator, to turn into the equivalent. So I've got 1/3 here and I need to turn 1/3 into 9ths. So here's my 1/3 on the bar model. 3 times what makes 9? Well, I know that 3 times 3 is 9, so I've divided my bar model there, you can see, into 3. 3 times 3 is 9, therefore 1 times 3 is going to be 3. So 1/3 is equal to 3/9. Now I've made this fraction an equivalent with the same denominator, I can now add the fractions together. 3/9 add 3/9 equals 6/9. Let's have a look at another example. This is the example from before, from the concept cartoon that you had a little look at. So let's see if any of the children were right and if any of their explanations were any good. So we've got 2 24ths add 1/6. Obviously our 1/6 here is what we want to turn our 6 into 24. So we're finding an equivalent fraction, 1/6 into 24. So how many 6's go into 24? 6 multiplied by 4 is 24. Therefore 1 multiplied by 4 is 4. So you can see here, here's our equivalent fraction, 1/6 is equal to 4 24ths. Now this fraction has the same denominator as this fraction, we can add them together. 2 24ths add 4 24ths is 6 24ths. So actually Rory, I think it was correct, but he obviously needs to work on explaining how he knew he was correct, and it's all about finding this equivalent fraction. Let's have a look at subtracting then two fractions with different denominators. 9/16 subtract 2/4. Now again, we're going to be finding an equivalent fraction for the denominator, which is the smallest. So we can see here we've got 2/4 and we want to turn it into 16ths. So 4 times what is 16? 4 times 4 is 16. So let's do the same to the top. 2 times 4 is obviously 8. So we've got 8/16 now. So now we have 9/16 subtract 8/16, which is equal to 1/16. And that is what we're going to be working on today. So you're going to have a go at adding fractions with different denominators and subtracting fractions with different denominators. If you find this quite tricky today, it might be worth going back and doing some practice on finding the equivalents first. We look forward to seeing your work today. Thank you very much.